All right, lesson 3-3 is over comparing linear and nonlinear functions. So after today, you're going to be able to use different representations to compare linear and nonlinear, comparing linear to linear, or also a linear to, again, a nonlinear function. So we're going to start with comparing two linear functions. So an auto assembly factory needs to purchase new welding robots. The factory manager has information on two different models of welding robots. The welding rates for each model are shown below. One is in a table, one is in a graph. We want to see how do the welding rates for the two robots compare. So we need to start by finding the welding rate or the constant rate of change for each robot. If you remember the constant rate of change, that's the same as your slope. Okay, so we need to find the slope for both models. So starting with the model T1000, we have the time. Again, this is going to be represented by our X or our input, and then the number of welding tests is our Y value because the number of welding tests is depending on how much time there is. So when we're looking at our constant rate of change, you're looking at the rate that it grew on your Y and the rate that it grew or went down on the time. So from 20.8 to 50.2, if I subtract those, I get 31.2. And then over here from 2 to 5, this went up 3. And again, when you're finding your slope, you take the change in Y, so 31.2, divided by the change in X, which is 3, and when you divide that out, you get 10.4. So that's saying that the Model T1000 makes 10.4 welding tasks a minute. Then we have the Model GNX 007. The information that was not printed on the graph here was they actually gave us the information for the rate of change. Since it's hard to tell on the graph exactly where these points lie, they told us that there was an 11.2 vertical change on our Y and a 1 change from left to right. So this went up 11.2 and over 1. So looking at this, my vertical change is 11.2 over 1, which is just 11.2. So here's my constant rate of change for Model T1000, and here's my constant rate of change for the Model GNX 007. Second step is to find the initial value and see where each robot started. So looking at their initial values for the graph, at 0, it made 0 robots. For this one, when it's in a table, if you're trying to find the initial value in a table, you have to almost work backwards to figure out how to get to your 0 for the X. So if I look at this as a table, okay, we went 0, 1, 2. Okay, at 2 it made 20.8. Our slope was 10.4 per minute, so if I subtract 10.4 from 20.8, that would mean that at 1 minute it made 10.4, and if I subtract 10.4 again, that means that at 0 minutes it made 0, because 10.4 minus 10.4 is 0. So I essentially subtracted my rate of change so that I could work backwards to see how much it made at 0 minutes. So since they had the same starting number, since I know that they each are only making 0 at 0 minutes, I really need to be looking at their constant rate of change. So since this one is making more per minute, this model is going to be more effective for this task. So I would say that the Model GNX 007 has a greater rate of change. Okay, so looking at the two functions and being able to compare their initial values, being able to compare their rate of change. You can also do this with linear and nonlinear functions. So here we have a square with a side length s is shown. The table shows the relationship between the side length and the perimeter as the side length increases. The graph shows the relationship between the side length and area. Okay, so this is showing us for perimeter. So if my side length is 1, I would have to add 1 plus 1 plus 1 plus 1 on all four sides of my square, which would put me at 4. So this relation is a function. Each input has only one output. If I'm looking at the slope or the constant rate of change for this one on my, again, input, output, x, y, on my y, this went up 4. On my x, it went up 1. So it has a constant rate of change. It is a linear function because it has a constant rate of change. Now, to make sure that it has a constant rate of change, you actually need to check to make sure that as you move along this table, the rate of change doesn't differ between these points. So I need to make sure that it's always going to simplify to 4 over 1. So all of these are going up 4 and over 1. So because of that, I know that this is linear because all of these are the same. Okay. On the other hand, you have this graph, which is showing the area. So if you're thinking about area of a square, if I do 2 times 2, that'll be 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And so on. It gets increasingly greater. This relation is a function also because it passes the vertical line test. There's no points on here where there's 2 y values for any of my x values, but it doesn't have a constant rate of change. It's not growing by the same amount each time. It's getting more and more spread out here, higher and higher. The farther you go on your x's, the area increases greater. So because of that, it's considered a nonlinear function. Both relationships are functions. And both perimeter and area are functions of side length. So that's really the only thing that these two have in common. So it was asking how do they compare. They're both functions. One's linear, one's nonlinear. So the thing that they have in common is that they're functions. All right, and then the third example, compare properties of linear functions. So this is when you're given two, looking at their rate of change, looking at their initial value. So for this example, function A, they gave me an equation. So I have y equals 2x minus 3. If you remember back when we did linear relationships and your form was y equals mx plus b, the m was your slope or your rate of change and the b was your y-intercept. So in this case, my rate of change is 2. So I can say the constant rate of change is 2. And I can also say that the initial value is -3 because that's what my b is, my y-intercept. That's the same as initial value. For function b, my initial value is found, or my y-intercept is found where this line crosses the y-axis, so the initial value is 7. And then looking at my slope, it went down 1 over 2, so my constant rate of change is going to be -1/2. So if I were to compare these two, I would say that function A has a greater rate of change. But function B has a greater initial value. So being able to pull out the two pieces of information and then compare them using some sentences. So you're going to have to do a little bit of writing on the homework to be able to compare the two functions that you're given. So function B has a greater initial value. And just like last chapter, two main things. You're looking for the slope or the constant rate of change, and you're looking for the initial value or the y-intercept. All right, that's everything you need to know about comparing linear and nonlinear functions.